Residual Analysis and Transformations, our tutorial. With the introduction of linear regression, we also learned a few tools that measured how well a linear relationship describes the actual relationship between two quantitative variables. Some of these tools included the coefficient of determination, r squared, or hypothesis testing for whether the slope equals to 0 or not. The new method you discussed today was an investigation into the residuals. For this tutorial, we will focus on the life expectancy dataset that includes the GDP per capita for each country. Let's set our working directory and read in this dataset. We will give each column their appropriate names, starting with the first column country, then life expectancy or life EXP, then GDP and HIV. We will attach these variable names and view the first few observations with the head command to make sure that our labeling was done properly. We are interested in life expectancy as a linear function of GDP, so we will begin with the command lm to obtain the line of best fit, or the regression equation. Recall that the form for an lm equation is predictor tilde response, so we will enter life exp tilde GDP. Now we can plot the data in a scatter plot with the predictor variable GDP as the first entry and the response variable life exp as the second, and plot the line of best fit, which is saved under linreg, with the command abline. The relationship between life expectancy and GDP doesn't seem to be described very well by the line of best fit, since there are many measurements far from the line. This definitely warrants an investigation into the residuals of this linear model. We can save the residuals from our linear regression under the variable name resids, and plot them against the predictor variable GDP to see if we observe any trends. For reference, you can plot a vertical line at 0 with the command abline, h, which stands for horizontal, equal to 0. We definitely see a trend in the residuals. For low and high values of GDP, we see mostly negative residuals, and for average values of GDP, mostly positive residuals. In the lecture, Jeff also discussed the possibility that a transformation of variables might be able to correct certain trends in the residuals. He examined the effect of transforming GDP by taking its logarithm base 10. Let's define a new variable, log GDP, which we will set equal to log 10 of GDP. Then we will obtain again the line of best fit with log GDP as the response. The scatter plot with the line of best fit now looks better. Let's check the residuals. We can save the residuals of this new line of best fit, linreg log, under resids log, and plot them against log GDP, the predictor. Even the graph of residuals seems to be better, therefore implying a better fit of a linear model to the transformed data. Checking a plot of residuals is a very important step in model fitting, and it can possibly lead to a transformation of variables. Keep that in mind the next time you do your next analysis.